So we have at 10 a.m. Bob leaves his office and begins heading toward his house, which is 40 miles directly south of his office at a rate of 30 miles per hour. Sally leaves her office at 10:20 a.m. and begins heading towards the same house, which is 30 miles directly east of her office at a rate of 42 miles per hour. How fast is the distance between their cars decreasing at 10:30 a.m.? So let's first get an image of what's going on. So let's say here's the house. So we'll call that point H. Bob is directly north of that because he heads south. So there's Bob, is Bob's office, and Sally is heading east. So we'll put her, the house is to the east, so let's actually put her over here. And she's going that way towards the house. Bob is going this way. And there is some distance between them. Okay, now within our drawing, what we want to do is label anything that's constant with that constant, anything that's changing with the variable. The distance between them is changing, so we'll call it D. This distance here is changing, perhaps we might call it X, and this distance here is changing, perhaps we might call it Y. Now, very quickly, you might see a relationship between these three variables because we have a right triangle. We know that x squared plus y squared has to be equal to d squared. Now, let's see what else we know. We know that Bob is going south at 30 miles an hour. That means this y is decreasing by 30 miles per hour. So dy dt is a negative 30. Also, dx dt, we can find that because that's going to be Sally's speed, and she's going negative 42. Now again, you may think, why negative? Because we were given their velocities and they're heading forward, but think about what's happening. The length of y is decreasing and the length of x is decreasing as they get closer to the house, so we want those to be represented by negative rates. The next question is, when are we trying to find? So we're looking at the distance between them. It's this change in distance with respect to time that we are looking for. Now, we can get a relationship between those rates by doing our implicit differentiation. So x squared is 2x dx dt. Y squared is 2y dy dt. And this capital D squared is 2 times d dd dt. So now we need to figure out, we know dx dt, we know dy dt, dd dt is what we're looking for. But we need values for x, y, and d. Well, we're looking for this at specifically 10:30 a.m. So we want the length of x at that point and the length of y at that point. Now we know initially Sally, her office is 30 miles. And we know initially Bob's office is 40 miles. But we're not looking for that initial, right? We're looking for what x and y are at 10:30 a.m. So Bob left at 10 a.m. going 30 miles per hour. At 10:30 a.m. we need to think about how far Bob has gone. He'll have gone exactly halfway because he's been traveling for 30 minutes or half an hour. We know he's doing 30 miles an hour. So in half an hour he would have gone 15 miles. So he's not actually, he's not quite halfway. He would have gone 15 miles, which leaves a remainder of 25 miles. We're going to do a similar thing with Sally. Sally was 30 miles directly east, and she left at 10:20, so she's only been driving for 10 minutes. So that's 1/6 of an hour. So 1/6 of 42 is 7 miles. So she's only covered 7 miles so far. She still has 23 miles left to go. So what we're doing is we're calculating how far they would have gone at those rates for those times. So now we have the x and the y that we need. So at this time, at 10:30, x, remember it's the distance left, x equals 23, y equals 25. Now we still need d, but that's okay. We do have a relationship between x, y, and d. So d is going to be the square root of 23 squared plus 25 squared, which we're going to do it as a radical for right now. And if we do 23 squared plus 25 squared, we get the square root of 1,154. Now we're going to plug everything we know into this problem and solve for our unknown. And one of the things that you may have noticed, all of them are multiplied by 2. If you wanted to divide everything by 2, that'd be fine to make it a little bit less to deal with. So we have x, which is 23 times our negative 30, plus y, which is our 25, times our negative 42, our d, which is right now in the form of rad 1154, and then times our d, this should be a capital D here, our d dt, which is what we're looking for. So we're going to need to divide both sides by square root of 1154 to get our d dt. So putting this all together, we have to do the computations. So we do 23 times negative 30 plus 25 times negative 42 all over that square root of 1154. And we get d dt is approximately negative 51.22. And now the units on that are going to be in miles per hour. So we get that, let's write it one more time, d dt, the distance between them is changing at approximately negative 51.22 miles per hour.